This is the warm-up for lesson 11, so take a bit and try to do this warm-up. You'll pause your player. So let's do this. We're going to distribute a 3, so we'll get 6x plus 27 less than or equal to negative 4x plus 12. And now, what do we want to do? Let's get our x's on one side and our constants on the other side. So we want to get our x's. Let's look at moving our negative 4x to the left side, because that'll make a positive x on our left side. And so if I'm moving my variables to the left, let's move our constants to the right. So let's subtract 27 from both sides. We get 10x less than or equal to, and 27 plus, or negative 27 plus 12, or 12 minus 27 is negative 15. We'll divide by 10, and what goes into both negative 15 and 10? 5 does. 5 goes into negative 15 negative 3 times. 5 goes into 10 twice. And we would read this as all real numbers less than or equal to negative 3/2. So on our graph, we'd have a number line. We're at negative 3/2, which means we'd be in between negative 2 and negative 1. We've got the equal sign, so I know that we're going to be a closed circle. And less than goes to the left. So let's look at our other problem. Our other problem is a compound inequality. I know that because I've got two inequality symbols. So we're going to work our way backwards through our order of operations just like we would. I'm going to undo addition and subtraction before I undo multiplication and division. Negative 7 plus 1 makes negative 6. One simplify out, and 5 plus 1 makes positive 6. Make that a little nicer. Now, what do we need to do? Now we need to divide by negative 6. So I'm dividing each side by negative 6. When we divide by a negative, what do we need to do to those inequality symbols? We need to reverse the inequality symbols. Make sure we don't forget to do that. Negative 6 divided by negative 6 is positive 1, and 6 divided by negative 6 is negative 1. So now if I look at this problem, my numbers aren't in order anymore. I've got 1, which is bigger than negative 1. So if I get something like that where my numbers aren't in order anymore, I'm going to rewrite them, and it might tell me something like that my problems might be just a little bit different. So let's try it here. So I'm going to rewrite this with negative 1 on the left and positive 1 on the right, just like I would on a number line. My x is still in the middle, and now we look between the x and the negative 1, we were eating or open to the x, so I'm going to stay open to the x. Between the x and the 1, we were eating the 1, so I'm going to stay open to the 1. And so now if we were to read this, we'd say that we were all real numbers greater than negative 1 and less than positive 1. So on our number line, we've got negative 1 just like on our, and 1, 0 in the middle if we wanted to. And at negative 1 we are greater than negative 1, so that's an open circle going to the right. And we are less than 1, open circle going to the left. So that's our warm-up. Homework questions we'll skip. We'll do that in class. So today is lesson 11, which is word problems. So first, some strategies to solve word problems. And this isn't in any order, and there's way more strategies than this, but these are a couple of them that I use on a regular basis. The first strategy is I want to try to understand or pick out the useful information. Sometimes there's information there, but it's not really having anything to do with the problem that we're trying to solve. So we'd call that erroneous information. Second strategy, to write a verbal model. So that would just be, you know, in your own words, what are we trying to solve? What are we trying to do? Third strategy, to draw a picture or to make a table, like a chart. Not an actual table like something you'd eat on, but a chart table, a spreadsheet, maybe. 4 would be to make an equation, and 5 is to identify the key words. So that's not in any order. Maybe 4 would be the very last thing that we do if we were to order this. So with that, there are some key words that we want to be familiar with, and you can write these down, or just you should know them. Addition keywords, subtraction keywords, multiplication keywords, and division keywords. There's more words than this, but this is you know, quite a few that tells us. If I say all together, that's an addition. All together, I have 7 apples. If I had 3 apples and 4 apples, how many apples do I have all together? That would mean to add my apples. Okay. So it's just some practice on some word problems here. Lincoln High's enrollment decreased at an average rate of 75 students per year. So when I'm reading this, I'll just go through and, all right, so we're decreasing. What kind of word is decreasing? I think that usually means to subtract. At an average rate of 75 students per year, so 75 students per year, that's meaning that each year it's going decreasing. That would mean I'm going down by 75 students per year. So that's Lincoln's High's. And then we've got, it says, while Erie High's enrollment increases at an average rate of 60 students per year. So I've got Erie High, and they increase at 60 students per year. Lincoln High has 3,150 students, and Erie High has 2,475 students. If enrollments continue to change at the same rates, when will the two schools have an equal number of students? So write a verbal model of this problem. So the verbal model, you know, let's still underline this. So we've got Lincoln High, and then we've got Erie High, and our verbal model is, you know, when will Lincoln High be equal to Erie High? So that's a fine verbal model. When is this going to happen? Write an equation for that model. So the equation for this model, well, Lincoln High is at what right now? Lincoln High is at, where do we have it? 3,150 students. So Lincoln High is 3,150 students. And what's happening over at Lincoln High? Decreasing at a rate of 75 students per year. So how could I write that into some sort of equation to go along with this? Well, I start at 3,100 and I decrease by 75 students per year. So I'd say if I'm decreasing, I'm subtracting 75 students per year. So let's just say each Y. 1 year, if I plugged in a 1, I'd subtract 75. If I plugged in a 2, 2 times 75, 150. I'd be subtracting 150, and so on. So that one needs to equal Erie High. Well, Erie High said they've got 2475 in students, so 2475, or 2,475, and they're not decreasing, they're increasing. So what kind of word is increasing would be an addition word at a rate of 60 students per year, so that would be 60 students per year y. So now we can solve, we've got an equation, and now we can solve the equation and get an answer. So what are we going to do? I look at this and I say, well, let's move my y's to the right side because I'm going to, because that'll keep them positive. So if I'm going to move my y's to the right side, that would keep it positive. So I have 75 and 60 that I'm adding together. And if I'm moving my variables to the right side, I want to move my constants to the left, so I'm going to subtract 2475, subtract 2475. So 3150 minus 2475. This turns into 675, and that equals 60 and 75 add together to make 135y. So what are we going to do? We'll divide by 135. Divide by 135. So y equals 5. So that means after 5 years, we're going to have the same amount of students. So what could we do? We could figure that out. We could substitute in a 5 either here, or we could substitute a 5 in there, and we'd be able to do that. So let's do it. What's 75 times 5? 75 times 5 is 375, so 3,150 minus 375 is 2,775. So after those 5 years, both schools should have 2,775 students. Next problem. On Pennsylvania's interstate highway, the speed limit is 65 miles per hour. The minimum speed is 45 miles per hour. Write a compound inequality that represents the speeds at which you may legally drive. Compound inequality means that we want to have two inequality symbols. Well, that's good because they gave us two speed limits here. We've got a speed limit of 65 and a minimum speed of 45, so those are my two numbers. I'll write them in order from least to greatest, so 45 and 65. What do we have in the middle of a compound inequality? We've got a variable, and we want to be, if this is saying the speed limit is 65, technically we don't want to go above 65. Can we go 65 miles an hour? Well, I hope so. So we're going to be less than or equal to 65. And the minimum speed, so we want to be more than 45 or equal to, so that would be greater than or equal to 45. So this is the compound inequality. We'd read this, all real numbers greater than or equal to 45 and less than or equal to 65. We'd graph it. 45, 65. Right here we've got a equal sign, so we know we're going to be a solid circle or a closed circle. We're greater than 45. Here we have a equal sign, so that's another closed circle, but we're less than 65. So what are our solutions? Is everything in here from 45, including 45, all the way to 65. Our homework tonight is homework 11.